All right, let's get started. It is exactly 3 minutes past the hour, and I would like to welcome you to our webinar from clusters to CDNs. And today we'll be talking about how you can do multi-tenancy deployments using the Varnish controller and the ideas that we'll be using the Varnish controller, which I'll introduce shortly, to build our own CDN. That's what we're going to do today. So this is supposed to take about 45 minutes, of which 30 minutes are spent actually building out our CDN. Now, without any further ado, I'd like to introduce myself. Hi, I'm Thijs. I'm Belgium. I'm based in Belgium right now. So usually I would say good morning instinctively, knowing that it's not morning where you're at. It's very much the afternoon. I'm the technical evangelist at Varnish Software. And I'm not alone today. As you may have noticed, I have a colleague here with me. His name is Henry Choi. Hi, Henry. Introduce
Hi,
yourself to
Taze.
our lovely audience.
Hey, thanks, Taze. Hey, everyone. Good afternoon, should be. So most of them probably we have talked about it. We met before. So I'm Henry, and I'm the solution consultant based in Singapore today. So, Taze, let's start.
Yeah. So thanks, Henry. The idea is that Henry will assist me with the communication today. So that means if you have any urgent questions throughout the presentation, you can ask it in the Q&A, and Henry is responsible for managing that. And if there is something interesting or something urgent, he will interrupt me and then I will answer your question. But don't worry, if you're not up for asking questions ad hoc, we still have a Q&A section at the end. So that's how things are going to go today. Now, today, as I mentioned, I'm going to talk about the Varnish controller, which is our brand new management and administration software. It's actually the successor of the Varnish administration console, our first product, and it's not added features, it's a complete overhaul. We started from scratch because we wanted to build something that scales along both in terms of features and in terms of performance. It will be an integrated product, but right now it's primarily built for deployment, so deploying new setups. And this is what it looks like. So we call it the Varnish controller, but in reality, there's multiple independent components that make up the Varnish controller. They're scalable independently, and they have no direct relationship with one another. They just plug in together and all in one, it's called the Varnish controller. But in reality, or as things go in practice, the goal is to provide a smooth experience for clients trying to consume content. And if you have multiple Varnish servers, maybe some of them need different configurations. Some of them may serve different behavior based on the domain name you're accessing. So the goal for the controller is to provision these Varnish servers with the right VCL at this point. In the future, a lot more functionality will be added. On the Varnish nodes, you'll have a small piece of agent software, which is the Varnish controller agent, which is responsible for communicating with the controller. So that's a bit of the back and forth that happens. This communication happens asynchronously, and it happens using a message queue, as you can see in this diagram. Currently, we chose Nats because it's a very good open source message queuing system, but we're not married to the technology. It's pluggable, so we can pull it out and pull something else in between. Now, the heart and the soul of the Varnish controller are the controller brains, as we call them. The brains is a component, the central component that communicates both with the Nats message queue as well as a database. The database is there to keep track of state. Now, all the other components that you see, such as the API gateway and the Varnish controller dashboard, are there to provide user input and make sure that instead of just getting information from the agents, you can also push information to the agents. Everything is API driven, so the API gateway is front and center in terms of the user experience, so that both the CLI, which is the command line tools, and the API can be called directly by the user. However, there's also a graphical element, the Varnish controller dashboard, which also is connected to the API gateway, and that provides a user interface. And demo will primarily be done with the user interface. You'll see that. Now, I mentioned before that this first iteration of the Varnish controller is primarily focused on VCL deployment. In order to fully grasp all those concepts, I show you this drawing, this diagram. So the goal is to deploy VCL, which is our entity all the way on the right, to deploy to the Varnish server. Now, the Varnish server is managed by an agent. So the agent is the entity all the way on the left. And you see that there's different entities in between. The VCL doesn't come as a standalone file. It's part of a VCL group, and this group can be deployed. So you have the concept of a deployment, the concept of a VCL group. The deployment is done based on tags. So if a deployment has tags and the agent matches those tags, well, that deployment will deploy the VCL file there. And there is a sense of multi-tenancy, both in terms of management as in terms of consumption. The management part we'll see in a minute, but in terms of consumption, we can make sure that the VCL configuration, which is the Varnish configuration language, which is the programming language that we use to determine the behavior of Varnish, that this is applicable on a domain level basis, meaning that you can have one server where multiple VCL files will be hosted, and each one may be applicable for a single domain. But it's also possible to not apply domains to VCL groups and have a root level deployment. And you'll see all this. I just wanted to highlight this, so once you see the graphical user interface, that it's not confusing. You see that most things, or nearly all things, are one-to-many or many-to-many. Now, our goal is not to make sure that the Varnish controller only does VCL deployment. It will become a fully integrated product, and all the other features that we're currently working on will find their way to the controller. The controller will be the single point of entry in terms of the user experience. So we're currently working on making sure that there's a request routing product in there, and every other product that we're building will be integrated in there. Long gone are the days where a project team is working on a product and will build their own graphical user interface. Everything will be integrated in the API, in the GUI, in the CLI. That being said, today we're going to use this to build our own CDN. And you may ask yourself the question, why would you build your own CDN? There's services out there, CDN services, and that is true. And mind you, my goal is not to undermine them or criticize them, because as a matter of fact, we partner with a lot of CDN providers, and some CDN providers actually built their software or built their platform using Varnish software services. But there are use cases, plenty of those. Our clientele is the target audience for that, where a shared service doesn't do the job for them. They need a dedicated CDN just for them, both from a control perspective as from a security perspective. Because it's not a black box, you have a lot more control. You can tune the things exactly to your needs. And if you play your cards right, that will reduce cost. It's also used in hybrid setups where traditional CDNs might not have coverage in the area that you want to operate in. So it makes sense to create a point of presence yourself using our software. And for a lot of them, it's also a hybrid way to do origin protection, origin shielding, whereas the CDN has many points of presence globally, and you just build a local CDN to ensure that your origin survives if all these nodes trying to reconnect. And when you already have the infrastructure and the networking capabilities because of your core business, it might make sense to just have the software rather than an external platform. Now, these are just a couple of reasons why you would do that. We'll not talk, we won't focus anymore on the why, but rather on the how. And this is what we're going to build today. This is the diagram. I'm going to use Amazon Web Services today, not because this is a cloud-only domain of application, but because it's easy to spin up and tear down infrastructure. It's very important. It's actually crucial to understand that these concepts, this DIY CDN, or rather private CDN setup, can also be done on-premise and in various cloud environments. So I'm using AWS just for the sake of flexibility. The goal is to have 3 different POPs. POPs stand for point of presence. So we have presence in the United States, presence in the Asia Pacific region. And the goal today is to create an EU point of presence to make sure that we're covered in these 3 big areas. The origin, so the server that we're trying to offload, is hosted in the United States. It will be a site that has both just visuals, web content, and a video streaming platform attached to it. And because of maybe popularity from a marketing perspective, we need to make sure all of that is offloaded if thousands or maybe even millions of people are accessing this content at the same time. Hence the need for multi-origin or multi-region CDN. What you also see is that you have 2 tiers in this, and this also makes sense. At the top end, you see the edge tier. The edge is at the outer edge of your platform, and the goal for these nodes is to be as close as possible to the end user. That is because if you operate on a global scale, despite the fact that there's tons of fiber optic cable on land and undersea, there's still latency involved. Like if you're based in Asia and consuming stuff directly from the US or Europe, it might miss a little bit of punch. And you want to have that punch, you want to have that responsiveness, and you want to reduce the latency by putting nodes as close to the consumer as possible. There's also a secondary tier, a storage tier, and that is also a caching tier using Varnish that scales out horizontally. So if you have a big catalog of data to be cached, for example, a video streaming platform, this will allow you to scale out horizontally and to ensure that there's enough caching capabilities for that. The way this is scaled horizontally is because the edge tier is using sharding, it's using consistent hashing to ensure that a request for a URL always ends up on the same storage node. And in that way, by adding storage servers, you can just horizontally scale out your caching capacity. So that's the deal today. This slide, we'll go back and forth to that as we need it, as I explain concepts. The thing that ties it all together is what you see on top, the Route 53 GeoDNS. So Route 53 is a service by Amazon, but a lot of competing products and competing cloud vendors have similar products. What it does is it does DNS, but it has geographical awareness. So based on a DNS request from a client, we can know where that person is located, and then we can route traffic to the right point of presence. So that is the goal today. Without any further ado, that was the intro. Let's get started. So I'll keep this one close. We might need it at some point in time. And I'm going to take you to this very simplistic self-built page. So the aesthetics don't really matter. This is a single pager. And this is our origin server hosted at origin.diy-cdn-varnishsoftware.com. It is hosted in the US, so it says US origin. And I've added this page render timestamp. So as I refresh the page, you will see that the timestamp updates. And this is a trick that we'll use throughout the presentation. If I refresh and the timestamp updates, content is not cached. If I refresh and the timestamp stays the same, well, the content is cached. You see, if you obviously see this big play button in US version. I'm using HLS for this. This is HTTP live streaming. And what I am streaming is a royalty-free open source video anime that I've annotated with a banner. So this is the US version. Eventually, I'll show you different versions of the content, but for now, content is hosted in the United States, website is hosted in the United States, and allow me to show you the page source. Page source wise, we are loading a CSS file. In our inline CSS for the page itself, we're loading a background image, we're loading a logo, and then obviously the JavaScript for the video. And then most importantly, we have this video tag. And as a subordinate tag, we have the source tag, and the source states where the video can be found. In this case, the video can be found on a folder called HLS, and then there's this file called video US M3U8. Now this M3U8 file is a playlist, and it mentions all the little bits and pieces, all the video files. So let's inspect the output and see what is actually going on. So if I go to the network tab and I refresh the page, a bunch of content will be loaded already. So let me show you what we have. We have the origin, of course, which is the website itself. We have the CSS, the JavaScript, the logo, but very interestingly, we have this one, the M3U8 file. And if I show you the response, you'll see how it works. This playlist has some metadata, which starts off with a hash sign. So it says that the target duration of each video segment is 3 seconds. And then you can see that as the playlist is loaded, all these video segments should be loaded. And this is actually the power of streaming. So we have 000.ts, 001.ts, and each of these files, as mentioned here, represents 2.44 seconds of video. And this goes on and on and on. And this is the power of streaming, because if we would fast forward in the video, we shouldn't load the entire file, we can load the right segment based on the manifest. It is interesting to spot that, like, to load this 15 to 20-minute video, we'll need to load 426 files. And this could become big real quickly. So if I start focusing on the AJAX calls now, you can see that the M3U8 file was loaded, and I already loaded the very first TS file, which is only at this point 70K. So if I start pressing the play button, you will see that all these video files are being loaded, and my transfer rate goes up quite rapidly, 27, 30 megabytes already, 40, and I think it will load 18 files, and then we'll keep on going. So the 18 files are buffered, and there's a whole lot of data being loaded at this point. So I'm pausing the video now, and we're over 100 megabytes, 110 megabytes have been loaded just for me. Imagine having thousands or maybe even millions of people going on to this, not only do you have lots of bandwidth being transferred, you also have a huge load on the system. And it's very realistic that the system will not cope with this and your origin will go down. So in order to prevent this, we need to build a CDN to ensure that all of this is cached on multiple tiers using software that is actually suited for this. And that is what Varnish will do for us. So allow me to show you what we have already, because our point of entry is Route 53. So what Route 53 will do is provide DNS records for the endpoints. And I've created various endpoints per region. So we have an APAC endpoint here, APAC DIY CDN Varnish software.com, and it points to 2 IP addresses. Now, if we remember the diagram correctly, these 2 IP addresses are the edge servers. So for APAC, IP address 1 points here, IP address 2 points here, and on and on and on. Now, it's also interesting to know that the end goal is not to have people navigate to apac.diy CDN. No, as you see, you also have, let's uncheck this and go here. You have a US version of it that also have different IPs. But the goal, the actual goal, is to create this, a www record. So if you go to www.diycdnvarnishsoftware.com, we'll point you to our APAC region, which has 2 IP addresses, so they will be load balanced. But this only happens if DNS request was located from Asia. So if you are located in Asia, which most of you are, I guess, you will be routed to our APAC endpoint. Also on the condition that the health check succeeds, and I'll show you the health check in a minute. There is something similar for the United States. So if you would go to www and you're located in North America and this health check in the US succeeds, we'll send you to the US endpoint. And for me, I'm a bit unlucky because there's no EU endpoint at this stage of the webinar. So if I would go to www from any other location, like I'm in the EU right now, I would be sent to the United States as well. So the goal is that we create an EU DIY CDN with 2 IP addresses and then attach it to www. So that is what we're going to do. Now, I'll quickly show you what is going on now. So if I refresh the www page, I need to show this to you, www.diy-cdn.varnishsoftware.com. I'm getting a US version, and that is not really what we want. So what we'll do now is we'll increase capacity in the EU from 0 servers to 5 servers, and then we'll manage everything using the controller. So I'm going to go to my AWS management software to make sure I'm in the right place. So this is EU. Ironically, I'm in London, which is it is debatable whether or not we're in the EU, but at least we're in Europe. So what I'm going to do now is I'm going to go to my auto scaling group because I prepared this, obviously, and I'm going to increase the capacity. So at this point, there are 0 servers in the EU, and we'll bump that up to 5, because if you remember the diagram correctly, and I'll bring it back, we need 5 servers in the EU. So let's make that happen. Desired capacity 5, click update, and at some point, they will pop up. But it's very unpredictable. It all depends on how busy it is at Amazon. So if I go to instances now, look, they're already, which gives me the time to go to the dashboard and to show you what this dashboard is like. This is the Varnish controller, and every good management software has a dashboard where you can see statistics. There's a little bit of traffic going on here, not a whole lot. So we'll create some artificial traffic to show this to you. So what I'm going to do now is I'm going to use Siege, and Siege is a benchmarking tool. So I'm going to go to the www record with a concurrency of 3. So 3 records at the same time, and -I is to do internet traffic. So it will load the JavaScript and the CSS and what have you. So you can see that the hit rate is going back and forth. You'll see smaller spikes in here. These numbers will bump up. So we have 117 misses now, but at some point, this will go up. So this is how the dashboard works. You see your top servers by requests, by hits, and by misses. So that's how this operates. You can see that the traffic is changing. But for now, we don't really care about that traffic. What we care about is our servers. So let's take a look at the servers menu item. So if I click it, I'll see an overview of servers. And luckily enough, things were quite fast. You can see that the EU servers are gradually provisioning. Well, they're already provisioned because they were already registered. So how does this registration process happen? If I take you back to one of the previous slides, you will see that there is agent software in place. Now, the agent has been familiarized with the endpoint of the controller. And as soon as it becomes available, it starts connecting to the NATS message queue and starts announcing itself. And that is exactly what happens. So these US and APAC servers were prepared by myself. So they already have the right tags for edge or storage. But in this case, EU was just provisioned by me, and it already has one single tag. I'm going to show you how that works. So if I go to my instances and to my launch configuration, which is the basis of the auto-scaling, I will click this here, and it shows you what the size of the images are and what AMI I'm using. Now, for reference, I'm using the Varnish Enterprise image that is readily available in the cloud. So if you want to operate in the cloud, we have pre-prepped images that don't require you to sign up in advance. You can just pay as you go, but we also have private deals. That's beyond the scope, but it's interesting to know that we have these images on AWS, on Azure, on Google Cloud, and various other platforms. So I'm leveraging those to quickly start up Varnish servers. And I'm attaching some user data, which is very interesting. So as all these servers get spun up, these user data keys are added. Varnish controller points to controller.diy CDN. So as soon as this machine becomes online, becomes available, it will connect to this one and will start provisioning. And I have a hard-coded tag here, which makes sense, tag EU. And that is why, ladies and gentlemen, that this EU tag is already available for us. So we have all this infrastructure available with which we can create our CDN. All the EU and APAC stuff is ready to go, but we still need to configure the EU. But as you can see, you see the host name of the server, its current state, how to connect to it over the IP address, what version of Varnish we're running. This is Varnish Enterprise 607R3, the tags, when it was created, and so on and so forth. So if I would click here on a server, you can see that there's already a deployment configuration attached to it. It's deployed in on two servers. It's using this VCL. So all of that is in place. The thing I will do right now is I'm going to start tagging my EU nodes. So I'm going to click the EU nodes. It's already an EU server, and I'm going to assign other tags. So I'm going to make sure that this is an Edge server, and we apply those changes. There's no automatic VCL group attachment to it because we haven't created one. I'll do that in a minute. This is our second EU server. This will also be an Edge node. Then we have 3 more servers to go, and these will be storage servers. And something interesting will happen now. So if I click select tags and I select storage, there's already a storage configuration going on. So if I click it and apply those changes, it will be automatically assigned with my storage system, which already has 6 servers in it and now has 7 in it. And it uses this storage configuration, which I will show you shortly. And I have to repeat that process twice for the storage servers. One more to go. And this is it. So now we have edge capacity and storage capacity, and the storage VCL is already automatically deployed on 9 servers. 9 makes sense again if we do the math here. 1, 2, 3, 4, 5, 6, 7, 8, 9. So all the storage nodes have gotten their capacity, but the edge nodes will have different configurations. There's an edge configuration for the US, one for the EU, which I'm about to create, and one for Asia Pacific. Now, before we can get into that, I need to make sure that the DNS records are properly configured. So I'm going back to the list, and I'm going to grab my EU edge IP addresses. This is the one, and this is another one. So I'll be picking that up right now, copying it, and we'll be going to my Route 53. And as I mentioned, I need to create this EU record now. So I'm going to do create record. I'm going to call this EU. And I'm going to assign this value. I'm going to lower the TTL for now. And we need the second one as well. So the 46 was required and the 135 as well. Copying, pasting, and this is it. At this point, we have a record called EU DIY CDN Varnish software.com. But now we also need to create the corresponding www record, which we'll do right now. So if I click create records and I add www, in this case, it won't be an A record. We won't be pointing it to an IP address or multiple IP addresses, but instead we're going to pick a C name, canonical name, and it will point to EU, hope I spelled this correctly, DIY-CDN.varnish-software.com. Now, mind you, this is not simple routing. This will be geolocation. And the location that we're going to choose is Europe, because I am based in Europe. The health check is going to point to my EU health check, which I'll show in a minute, and I'll call this EU. Now, again, I'm located in Belgium, and if I go to www, I'm still served from the United States. And this will make sure that we're not, as soon as this health check succeeds. I'm creating the record. And even though that record is created, I'm going to still be pointed to the United States because this health check is going to fail because we didn't deploy our edge yet. Now, in terms of health checking, I'll show you how that works. You have this option here called health checks in Route 53, and I predefined an EU health check. You can see that the EU is unhealthy and Asia Pacific and US are healthy. If I show you the details, you can see that our goal is to go to eu.diy-cdn-varnish-software.com/healthz, which is our endpoint for health checking. It does that every 10 seconds, and at least needs 2 failures to become down, and I guess 2 or 3 successful calls to be up. But because we don't have anything, this is not going to work. But we're going to resolve that right now. We're going to go back to our controller, and we're going to configure things. What we have is, and I forgot to mention that, is we have a set of domains as well. Our domains that we're going to use, US, APAC, EU, and WW, are configured here and can be used by our configurations. So if I'm going to these configurations right now, you can see that there is a storage configuration in place for specific domains deployed in 9 servers already. So if I click it, you will see that this configuration is called storage, and all these domains apply. So this configuration only applies to these host names. If something else would be hosted in our controller, these VCL files would not be used for it. Based on that, we have a deployment. So remember the diagram, VCL group, domains, deployments, VCL, this is all grouped together. So we have a deployment called storage, domain controller, I guess, and then you have a bunch of tags that you can assign with it. In this case, we have a single tag called storage, and 9 servers are matching it, which makes total sense because we have 3 regions. Each region has 3 storage servers. If you assign multiple tags, like if we would go for US here, only 3 servers would match. So that means that what we assign does it based on an AND operator. If you want an OR operator, you can create multiple deployments here, and that is as if you would do an OR, a logical OR. What happens is that this specific storage.vcl file, which I can click here and it will show you, and we'll walk over the VCL very shortly, will be responsible for setting the behavior of our storage service, and that will be automatically be deployed. We also have other configurations. For APAC, for example, we have an edge configuration, which will do the same thing, but it will assign it to edge and APAC, which only matches 2 servers and uses the edge APAC configuration. And there's a similar one for the United States. So what I'm going to do now is I'm going to go to the editor button, in which we can edit our VCL configurations. And the files that I talked about are already here. And because they have a green cloud next to it, it means they have already been deployed. Meaning that if I change anything and I press the save button here, it won't just save it, it will deploy it to all the attached servers. So if I make a change at storage.vcl and I press save, 9 servers will be affected. So let's quickly go over the VCL. The primary responsibility for a storage server is to fetch data from the origin if requests come in that are not cached. So if I go to the home page and it's not stored in cache, it will go to the origin, fetch it, and store it in cache. There's also mechanisms, and I'll show that near the end of the presentation, to invalidate the content while there's logic in here. So everything is based on this VCL programming language that hooks into various stages of sort of finite state machine. So this is extension of the behavior when we receive requests, This is extension of the behavior when the backend response and stuff was not cached. So the goal today is not to learn all about VCL. I just wanted to highlight some capabilities. Capabilities such as invalidating content protected by an ACL. So invalidation can only happen from Amazon's internal subnet or from the local host. Otherwise, we'll return an error, and the error would be purge not allowed for this client IP address. I showed you the health checks. All the health checks are based on this. So if we receive a request for health Z, we're artificially going to send this response back. This is a synthetic response saying 200 healthy. Then there's more logic in play. What we have here is stale if error logic, and that will ensure that if the storage server receives a request and whatever is stored in cache is outdated, so it needs to revalidate, that even though the backend, the origin might be down, we will revive the object and keep it longer to still provide this fluent experience. And then when the backend response happens, that means we had to send a request to the backend and the backend has responded. If the request was for an M3U8 file, you remember that file, it's the playlist of our HTTP live streaming, then we'll make sure it's only cached for a second. So if you do live streaming for live events, then this playlist is going to be updated constantly. So you'll cache it for a second. We assign cache invalidation tags to it. So this is HLS and a playlist. So if we would invalidate the playlist tag, so every playlist would be gone. So this is a way to invalidate based on tags. These TS files, which are our binary video files, have the same HLS key, but are TS files and will be cached for a full day. So that's how that works. And under all other circumstances, we will follow cache control specifications. So if you have a cache control header, we'll respect it. If you don't, in this case, we'll cache for an hour. So this VCL configuration allows you to override a whole lot of things. And then this is where we call the stale if error. And this is a custom response header that we inject to show you what the server IP address was. There's also storage, edge rather. And what we're going to do now is not going to run over or go over this one. I'd rather select everything, copy the content, the textual content, create a new one for the EU. So edge underscore EU.vcl. I'm clicking the create button, and now we have this brand new file, and I'm going to paste the content into it, and I need to make some slight modifications. So in this case, you see multiple backends. This is where we do the sharding. These IP addresses are obviously not the right ones. I need to insert EU one. So I'm going to the controller here, and I'm going to take it back to servers, and I'm going to pick the the EU rather, storage server. So I'm picking EU, applying the filter, and then we need these three IP addresses. 137, paste it here. Then we have the secondary one that ends with 26. And then we have the third one, which is 174. We're going to paste that in here, and this will ensure that when we receive requests that are not cached and we need to connect to the backend, that we connect to our three storage servers. But it does that, as you can see here, based on sharding. So it will use, and I will show you where that happens right here. When we need to fetch content, we'll use the URL. It will create a unique hash, and it will always select the same server based on logic. I already save it. We still need to make slight adjustments. So let's walk over it real quickly. This is where we initialize the backends and ensure that sharding can happen. The sharding is executed here at line 70. This is the logic to invalidate the cache, which I'll show you in a minute. Again, this is our health check. This is irrelevant now, but I'll show you near the end. This is, again, that same logic where we assign TTLs and TS files and M3U8 files. And this is interesting. So what I'm going to do right now is I'm going to replace content that was returned by the origin. So you may remember that this origin page returned US origin. For the sake of convenience, I'm going to replace that content using our Xbody module to EU pop. So it's clearly visible that we're we've manipulated the content and are hosting it in the EU. And then this debug header is also going to be used. So that's it right now. That is what we have. And let's get started. Let's create a configuration. So I'm clicking configuration, and we don't have an EU edge. So I'm creating a VCL group, calling it edge EU. And we can choose to make it a dedicated VCL, but we're not going to do that. We're going to apply it specifically to EU and www. In terms of tagging, we're going to select EU edge servers, apply those changes, and then select our VCL file. We can select it here. We can upload a new one. But what I'm going to do is I'm going to select the VCL file, use the EU one, apply it. So now we have two servers waiting for the deployment. So if I click create and deploy right now, it will send everything that way. So it has deployed it to 0 servers at this point, already to 1, to 2, deployment is done. It's not because the deployment is done that everything will work appropriately. So if I take you back to Route 53, the health check needs to succeed. Now the health check is unhealthy at this point because we've just created it. But if I go to this health checking right now, I can access the URL here, and you'll see 200 healthy. So everything is good. But I'm not sure if the DNS has already spotted this. So what I will do now is I'm going to make a DNS call to dig to www.DIYCDN-varnishsoftware.com. What dig does is it does a DNS call for the www. And what happens, it was quicker than expected, is that it already returns EU. So that is good news. This is very good news. So what I'm going to do right now is I'm going to switch to my browser, and I'm going to go to www, knowing that this was the US pop. So when I refresh the page, there we go, hurrah, we're in the EU. So it actually works. And mind you, you can actually go to it yourself where you're at. So if you're located in the US, you'll see US. And I guess because most of you are located in Asia Pacific, if you would go to www.diy-cdn.varnishsoftware.com, you will probably see it being hosted from our Singapore or from the Singapore data center. So that is what is going on right now. If I refresh it, well, then the timestamp remains the same. So nothing really special is going on here. And I can actually prove it. I have a setup here that has 3 windows. The left window is the EU data center, middle window is US data center, right window is APAC data center. So if I would broadcast to my screens and do a curl call to www and filter on the region output tag, you can see that this page is being rendered from the EU, this one from the US, and this one is rendered from APAC. So I guess our CDN is really working. But I'm going to show you how I came up with this output. So what I can do is I can do a curl. Let's see what we've got going on here. Curl -i, and -i will only output the headers. -s to silence the output. I'm going to go to HTTP and then www DIY-CDN-varnishsoftware.com. And this is the header output that we're getting. Some of which was injected by Varnish, some of which is was injected by myself in the VCL code. So the cache control header came from the origin and it set it to an hour. So this page is going to be cached for an hour. The keys, these are cache keys that were injected at the page level. So I selected this as to be a page, but also HLS. So that means if we're invalidating content, which we'll do in a minute, based on the HLS tag, the page will be gone. But as you've seen in the VCL, the M2U8 files and the TS file will be gone as well. This was something I injected here. This is the IP address of the storage server that was added, and the IP address of the edge server, and the region header. So all this data is there, and I can use that accordingly. So this is quite cool, actually. So what I will do now, and we've almost reached the end, is I'm going to invalidate some content, because there might be, let's say you have a news website and you're caching this multiple regions, and some breaking news appears, and you have to wait until it actually gets cached. Well, then you're in big trouble. So what you're seeing here is that this page can be cached for an hour, and at this point it has been in cache for 72 seconds. But at some point we want to remove this. We want to get rid of it. So let's see if I can show that to you. Let's do it in an easy way, because this is quite complicated. I'll explain what is going on. If we have to invalidate each node individually, it's going to be a very tedious process. So at this point, I think we have 15 servers just for caching. So we have to know the IP address of every single one of them. What we can do is actually call the broadcaster. And I've set up a broadcasting system, which is also part of our Varnish Enterprise product suite, whose responsibility it is to broadcast messages to an inventory of servers. So it will act on behalf of the Varnish servers. What I've done here in my cloud setup is use yet another enterprise tool called the Varnish discovery system. And that has certain awareness. It has an AWS plugin, so it can hook into my auto-scaling group and dynamically specify what the nodes are. So at this point, the EU broadcaster knows that there are 5 servers to be invalidated, and there's an US broadcaster. Well, it knows what the IP addresses of its 5 servers on, and the same applies to APAC. So if I would do a regular HTTP request, I'll get the output, but I'm not going to do a regular HTTP request. I'm going to send a purge request to it. And what this purge request will do is it will ask Varnish to invalidate pieces of content. What I'm also doing is I'm adding this specific Y key purge header, which is also part of the VCL. And I'm specifying that I want everything related to HLS gone. And I don't want this for EU broadcaster hostname. No, I want this for the www. So if I press this button, it replies and it says that these 5 servers have received a request, and they replied with a 200. And I could test this now. So if I go back to my browser, it was 740.08. If I refresh, whoops, 740.08. Let's try that again. Did I do something wrong here? I did. Something is glitchy, and I don't know what. Apologies. So what I'm going to try to do now is I'm going to do another purge call, but I'm going to, oh yeah, I think it makes sense because it was HLS. I'm going to just invalidate the one page. Let's see if that works. It did, 45.48. So if I refresh now, nothing will happen. If I invalidate again, 5 servers have been invalidated rather, and the timestamp will be updated again. Now this is only EU. I'm going to do this at a global scale. So I'm going to see if my command line history still has this. There we go. So what I'm going to do now is I'm going to invalidate the home page. Using the broadcaster, I'm going to specify EU, US, and APAC. So what is going to happen is that these 3 broadcasting systems will be called, and then all the nodes will be invalidated. So if I call this now, you can see that these 3 calls were made, and that in total 15 servers got invalidated. So regardless of the region, content got invalidated. So that is how we operated at this point. Now I already see some questions coming in. I will answer them shortly because I believe we've reached the end now of our demo, 45 minutes in. So what I will do now is I'm going to bring you back to our thank you slide. I'm going to start answering some questions. Henry, do you have some interesting questions for me? I see some stuff happened on the chat while I was doing the demo.
Yes, we use the chat instead of Q&A box, but you know, everyone can see the question right now. So yeah, it's pretty interesting because you are playing around with the HRS streaming. So yes, pretty much interesting to understand how it's working and how we can achieve the caching for live and VOD. What is the difference between live and VOD caching?
Well, for VOD caching, you know ahead of time what your capacity will be. Like for this little video that I showed you, which lasts 15 minutes, we already need a couple of gigabytes of storage. Now imagine that you have like a huge catalog and that you're even doing it in 4K. I just did it in 1080p. You'll have a lot of storage. But the good thing is that you know ahead of time what your capacity will be. You also know that your entry-await file, that the playlist file will be complete because you know all the segments. So in theory, you can actually say, well, I don't want this entry-await file to be cached for a second, as I did in my example. We know it's video on demand, so we're going to cache it for a day as well because it doesn't change. So from that respect, the only thing that matters for VOD is making sure that everything is cached so that you have a consistent experience. Because what will happen is if people start consuming maybe less popular content, maybe you have a couple of shows on HLS that are super popular, and then you have like this long tail piece of content that only a couple people watch. But still, those people who are watching it are probably paying you to view this, and they want the same experience. So that's why it's important to have enough caching storage so that even if these long tail shows, unpopular shows, aren't on the edge servers, they're still in the storage systems, and you still have a decent experience. Because the alternative would be that it's nor in edge nor in storage, but it has to come from the origin, and that's when things will be very slow. Especially like if I take you back to the diagram, if you're doing this, let's say you're in Singapore, and you're consuming content that is hosted originally in the United States, well, it will take a little bit of time, and that buffering time will prove to be unpleasant. But for live video, it's a bit more unpredictable. We have to set the TTL very low because we don't know how many segments there will be. Will the broadcast last for an hour? Will it last for half an hour? Who knows? So from that respect, it's a matter of getting those segments out as quickly as possible, because live video is very sensitive to latency, and Varnish will assist with that. Varnish also has some capabilities to ensure that when, like, let's say thousands of people at the same time are trying to catch like this brand new piece of video that is not yet stored in cache, to avoid that the origin will be overloaded. So this is very much an origin shielding principle, and the technology that we're using for that inside Varnish is called request coalescing. So Varnish will be clever enough to spot that all these requests will be pointed at the same resource at the origin, and it will queue all of them in parallel. We'll send a request, a single request to the origin to fetch that, in this case, video segment. And then as soon as the first bytes start coming in, it will stream all the content to all the people that were queued. So in this way, you still have the same user experience for the consumers, and you protect the origin. So that's a bit of the difference. That's where request coalescing will kick in. This was quite a lengthy response to a very simple question, but I hope it makes sense.
Yes, indeed. Actually, it's a very good feature for us. Other CDN doesn't have that, caching everything just on the first hit. But for us, we will see if the long tail content, we will see for the second or third hits, and then we will keep a cache because we don't want to waste our resources on the server. Yeah,
and that's actually quite a new feature. That's really interesting that you addressed this, Henry. Like an instinctive reaction for many people who operate caches is, as soon as a request comes in, it's not cached. Well, our goal is to fetch it from the origin and to store it in cache and make sure it's there for the sake of the user experience. But it's sometimes hard to predict if that content is ever going to be used in the future. So one of the latest features in Varnish was that you can configure in VCL that only the third miss or the second miss, or how you configure it, will result in it being stored. Otherwise, we can consider it a one-off. We can say maybe this person is consuming content and no one else is going to consume it again. So for the sake of efficiency, we're not going to store it in cache, but we're going to wait until someone else is trying to fetch it. So that is also efficient. So if you operate a CDN and you have petabytes of data to store, but you don't have petabytes of storage, it's making decisions and predictions on what you want to cache and what you don't want to cache. Anything else, Henry? Anything else coming in?
Yes, Thijs, we got another question, very interesting. Do we have a push mechanism for live streaming to our CDN at this moment?
So
I think
ingestion,
it is
you
talking
probably
about exactly.
ingestion. At this point, there's nothing from a product perspective, but from a technology perspective, there's always ways to ingest it. So the way I've done this is I used FFmpeg to create a video, because this open source video that I showed you and that you can consult yourself for the time being is just a single MP4 file, but HLS doesn't operate in a single MP4 file context. So what I did, this is video on demand, is I used a tool called FFmpeg that would convert it and turn it into HLS. And if need to, you can set up a pipeline where FFmpeg does this. There's competing tools as well, both open source and commercial, that could store it. Now, what I've done here, and you can still see the diagram, is we've set up this origin server where it can all end up. But if the only thing you're doing is video, there are even situations where you don't need an origin. And as long as you have enough storage, Varnish can fetch the files for you from disk and serve them directly without the need for an origin. So you can, if you want to, set up a pipeline where all these files are ingested and put there. Now, this is for video on demand. Live streaming is a different animal, if I may say so, because it needs to happen very rapidly. So I know FFmpeg can do it. I think I've done a meetup once where I set up a GoPro and used the RTMP protocol to stream from my GoPro to a server with FFmpeg, and FFmpeg would then transcode it to HLS and Varnish would serve it. So I've done situations where that is possible. But I think if you're a serious broadcaster, you'll probably have like enterprise prize grade stuff or professional stuff to do that for you. And Varnish is just a great match for content delivery and content distribution. So that is important to understand, that our core business is content delivery and acceleration, not necessarily the video aspect of it. There are many CDNs and many OTT video providers that use Varnish for the acceleration, but most of them have the tools in place to go, as they call it, from glass to glass. So from camera lens to clients. And we're just in there to accelerate it and to do the CDN part.
Good. Thijs, another question about the layering, because for your
Yes.
diagram, you have two levels of caching. What
Yes.
are the difference between the two layers?
Well, you're not forced to have two layers of caching. I can tell you that ahead of time. But what we're trying to do with the edge layer is do the basics of edge technology. So that means receive the request and do the necessary manipulation on the edge. And I think I could show that how we've done that throughout the demo, throughout the webinar. Let's have a look at the editor and take you back to the EU VCL file. So what this one does is do the health check, replace content on the edge, set the right cache key. So all of this is to present content in the format we want. So despite the fact that the origin presents content in a certain way, we still have the opportunity to do logic on the edge. That's the main responsibility. And also, this edge tier is basically also a load balancing system to balance the load correctly. It does have caching, and I would advise anyone operating an edge tier to just use memory for that. And knowing that only a fraction of the content is going to be served from cache, but its main responsibility is distributing requests that are not hot, so to speak, to our storage tier. Now, our storage tier is also Varnish, so it's also lightning fast. But what I failed to explain is that we have a proprietary technology called MSE, short for Massive Storage Engine, whose responsibility it is to store content on disk, but in a very ultra efficient way, and then buffer it to memory as required. So this will be our storage capacity, but there won't be a lot of logic happening there. It's just a matter of storing objects there, serving it to the edge. And if the content is hot, it will remain in the edge and the edge logic will apply, do some manipulations and serve it there. So long story short, the edges are there to balance the load and to store very hot content that is super popular and to redirect content to the right storage server. We've done this based on sharding so that you can scale out your storage tier horizontally. I've even seen setups with 3 tiers where you have an edge tier where the edge logic happens and the load balancing happens. a storage tier that only does storage, and then a tier behind it that does origin shielding. And the only thing it does, like we also have a web application firewall offering in Varnish Enterprise, does the security there and protects the origin from overloading. So you can have as many tiers as you want. Quite commonly, we use 2 tiers, one's for load balancing and one for storage. So I hope this answered your question, and apologies again for the very lengthy answer.
Yes.
Anything else?
Indeed.
This is a very interactive panel so far. I'm liking it. So thank you for being so responsive. It's much appreciated.
Lots of other questions, but I answered mostly. Another one, actually, we can talk about something like the edge computing. I think is related. So
yes.
This question from Edward: are there any good approach to handle API content, like single page application? I think it's more like dynamic pages or authentication thing.
Well, it is possible, definitely. And like what I've shown you is now the basics, but like we have tons of ways to do like edge computing and APIs. And what I would like to do now is I point you in the direction of our documentation page. So we have this docs page called docs.varnish-software.com. And if you go to Varnish Cache Plus and click documentation, you will see all the features we have and all the modules we have. So we have tons of modules that you can use for any domain of application. So I've just finished writing a new book about Varnish. So I had to go really in depth and look through all of it. And what I've done is, and if we combine APIs and edge compute, because that was the question you asked me, right, Henry? Edge compute and APIs.
Yes.
I've actually built examples where some like lightweight endpoints were completely handled in Varnish. So what I've done is used synthetic backends in this case to just create content on the spot. Let's see if we have a good example here. Yeah, like what you can actually do is create a string content based on a cookie value in here and just store it in cache without actually talking to any origin. So what you can do is you could present this as JSON content and serialize it as JSON, and then make the user believe that they're really connecting to the origin API, whereas in reality, all the decisions are made in Varnish. So Varnish can connect to Redis, Varnish can connect to other API endpoints, Varnish can talk to databases. So basically, some of the really heavy lifting that would overload an API, especially stateful stuff, such as authentication and like serving stateful data, we can actually do some of that in Varnish. And by doing that, offload a lot of it from the origin. So what we also have for APIs is JWT. Let's see if we have it here. So if authentication becomes too heavy on your origin system for your API, we can offload the authentication part using JSON Web Tokens on the edge. So you can actually validate and issue JWT tokens. So if you're operating an API that is under heavy stress, Varnish Enterprise is actually an excellent product for it. And we have the capabilities of offloading a lot of elements. So whoever asked that question, I hope this answers it. And if not, I would still like to provide you like a sort of soft landing. This is my email address. So if you would have any questions regarding this, I'd be happy to look into it and to provide a solution.
Good. Thank you, Thijs.
Thank you, Henry, for assisting me.
Another question. No problem. I would like to have the update on the book. So when do you think your book is ready?
Oh yeah, that's a different story. Like I've spent like it's very controversial what I'm going to say, but thanks to COVID, and I apologize for that, I was able to focus heavily on that book. So I spent a year writing it. I think it's going to be more than 500 pages. It is done now. It is submitted, and the publishing company is now like doing the layouts. So I hope secretly, I'm not sure if I can confirm this, that by the end of the month, you will have it in PDF version. And we have a landing page for it on our website. So if you want a copy, you can get it. And it will explain some of the concepts that I went over today, CDN aspects, but also very much in depth on all the bits and pieces of Varnish. So regardless of your domain of application, are you accelerating a website, a video streaming platform, or APIs? Well, then you'll find a lot of useful information on from a development point of view, but also from an ops point of view and how to manage all that. So stick tight, it's coming. I hope by the end of the month.
Could it be
All right.
okay to send the books to all our attendees today later on for free?
Well,
Yes.
what they should do is they should just register for the book page on our website. I think there is a link somewhere, and they should leave their credentials, and we will email a copy of the book once that is done. So I think we're exactly an hour in. So we've done extensive Q&A. I gave you a little bit of a rundown of what Varnish Controller could do and why you would build your own CDN. And we even went to the demo. So thank you. It's already late in the afternoon, I guess, in Asia. For me, the day is just getting started, but I would like to thank you for being here. It was very enjoyable, and I love the fact that it was so interactive. I hope there was some value for you. And if you have additional questions, I'm at Thijs on social media. Like if you want to reach me on Twitter, that's the place, or you can drop me an email at this address. And I see that marketing was friendly enough to include the link in the chat where you can sign up for the new book. With that being said, thank you again. Thank you for being part of this. I'll stop sharing my screen now, and I will see you next time. Stay tuned. Bye-bye.
Okay, bye. Thanks, Thijs. Thanks, everyone.